welcome to organic chemistry. Today we are going to see about the alkanes or alkyl halides, that is halogens containing organic molecules, especially the alkanes, one or two hydrogens with halogens, such a compounds we are calling alkyl halides or haloalkanes. Example for this case is H3CH2Cl. This is the best example of all the different haloalkanes. This taking ethyl chloride or chloroethane. Systematic nomenclature is chloroethane. However, by radical function name it is also called as chloride, ethyl chloride. That is the common name, but the systematically it is called chloroethane. Some preparations in the properties of this compound in the today's class. Let's take the of this ethyl chloride. The first method is take halogenation of alkanes. Alkanes can be halogenated, especially for example if ethane is taken, one of the hydrogen can be replaced by a suitable halogen by taking direct treatment with the chlorine in presence of the UV light. One chlorine, it takes a free radical substitution reaction. A free radical substitution reaction taking place, and you are getting the H and Cl will be removed as HCl. This is a simple reaction in the alkane chapter we have taken. This is a free radical substitution reaction. The other method is the addition of alkenes. So, you take ethylene and add HCl, ethylene to add HCl. Is seen in the types of reactions. First, H plus will be added as a step 1, either this side the Cl will be added, and you are going to get a ethyl chloride as a major compound. However, if you continue the reaction, in the case of alkanes you will get, but in this case you cannot further reaction also, because only one double bond is there. Even if you add excess HCl or excess time also, the final product will be the, that is the one advantage here. From alcohols, halogenation of alcohols. Alcohols like ROH, if you take, they can be for the chlorination method. You have PCl5, PCl3, PCl5. You can also use a SOCl2. This is known as a thionyl chloride. And one of this reagent, if you use the OH will be replaced by the RCl. Any one reagent you can use. Accordingly, you have to adjust the equation. In the PCl3, the Cls will come here, OH will go, you will get a POCl3, P with the RCls will be formed. In addition with the P will take up the OHs thrice. This will be the byproduct. Second case, the RCl will be formed in addition to this RCl 3, and the 2 moles of the HCl will be there, isn't it? So, that is Cl will be substituted, 1 HCl will be formed, and 3 Cls will be with the POCl3 will be. With the thionyl chloride, the R will become RCl, S will become SO2, and 1 HCl will be formed. So, depending upon the reagent, you have to adjust the product, but alcohol will be converted into the RCl. You have another method to convert the alcohol into the alcohol to alkyl chloride by using the anhydrous zinc chloride as a catalyst, but the concentrated HCl is the actual reagent. If you add only HCl, the reaction may not take place. In the case of here, what happens, the concentrated HCl will attack here and this water will be removed, and then this the Cl minus actually the anhydrous aluminum chloride, what is the role means the Cl minus first will be taken away by the concentrate this anhydrous zinc chloride. Will attack here, removal of the OH will be taking place. It passes into a carbocation intermediate, then the zinc chloride releases the Cl minus, Cl minus will replace. Because the Cl minus is a weak nucleophile which cannot replace the OH directly. So, therefore, we are using some indirect mechanism. The mixture of anhydrous zinc chloride and the concentrated HCl is called specifically Lucas reagent. Lucas reagent. The reagent has a application also with reference to the identification of alcohols. In the alcohol chapter, we degree 2 degree, 3 degree alcohols if you take, you add Lucas reagent, 3 degree will give immediately turbidity formation, because the alkyl halide formed is not soluble in the aqueous solution, they get a turbidity sort of reaction. So, that secondary will give 5 to 10 minutes time, primary even just waiting will not be the resulting reaction, and you will get the reaction. So, therefore, are having a one scope to differentiate the different types of the alcohols using this particular Lucas reagent. Okay. Then we will go for the some of the properties of these compounds. One or two from the acid derivatives also you can take, but the silver salt of the carboxylic acid when treated with bromine, you will get the RBR. The method is not useful for the preparation of the chloride, but for the bromination this is a very good method. You will get a silver byproduct plus carbon dioxide is removed. The reaction is a decarboxylation cum bromination. It is known as Hunsadecker reaction. Hunsadecker reaction. The name reaction, but the reaction is not suitable for the preparation of the ethyl chloride, but for the alkyl bromides the method is very much suitable. Now, let us go for the some properties of these compounds. Alkyl halide undergo one important reaction is a nucleophilic substitution reaction. The reaction can be shown as an alkyl if you treat it with a Y minus, where Y minus is a stronger the base or strong nucleophile. Then what is happening? The Y minus replace the X and you will get a RY type of the bond. So, the Y minus alone will not be possible, isn't it? So, therefore, you are taking many times a sodium salt of like a sodium cyanide, sodium the hydroxide, sodium amide and so on. Variety of anions are available. All these amines, the X happens to be a Cl, isn't it? So, Cl is a minus anion minus is a nucleophile which is obtained from the strong acid. So, therefore, conjugate acid base theory if we apply, HCl is a strong acid whose anion conjugate base is a weak base. So, therefore, it so happens the Cl minus can be replaced by the variety of nucleophiles and we are going to see here a few reactions of such a variety. The ethyl chloride, for example, if you treat it with the aqueous sodium hydroxide, sodium hydroxide dissolve in water and add it and boil it, the Cl is replaced by the OH. Now, you just concentrate on what type of product is coming, one aspect. The other one is what is the nucleophile is replacing the Cl minus, is it a stronger one or not? More the stronger, the better will be the nucleophilic substitution reaction taking place. And if you take NH2, sodamide, NaNH2, NH2 minus replace, you will get a amine. The first one is a alcohol, second one is a amine. And similarly, if you take a sodium salt of alcohol, OR minus, this OR minus will replace and you will get a COC. COC is a ether bond. This is a ether type of the compound, which is a name reaction. Alkoxides replacing the Cl, getting a ROR type ethers reaction is known as Williamson synthesis. Williamson synthesis. Similar the way the alkyl halides can be replaced by the variety of the other nucleophiles. We will extend this reaction on the other side. If the nucleophile is it so happens as alkyne with sodium salt of the acetylene. Acetylene will replace this halogen and you will get the alkylation here. Alkyne group will be introduced. You can take a benzene. Benzene, if you take anhydrous aluminum chloride, then this benzene polarizes into minus and the minus replace, you will get the Friedel-Crafts alkylation, you will get the ethyl chloride. If you take a sodium salt of the R minus, R minus will react on this Cl and you are getting a alkyl plus R. This is nothing but a Woods reaction. In the Woods reaction, in the core, several reactions R minus will be replacing, and it so happens R minus is the best nucleophile of all the different types of the anions. If you take a carboxylic acid RCOO minus a sodium salt, if you take, the minus will attack here and you will get an ester. OCOCH3 is an ester is formed, isn't it? Or let us take ester. This is alkane. This is alkyl benzenes, alkynes. So we have a huge number of reactions which replaces this Cl. Okay, right. Now let us take another set of reactions which are also similar in this way. In ethyl chloride, if you take sodium cyanide, what is the anion or the nucleophile? Cyanide minus. Where is this minus charge means Na will be plus, however the C triple bond on the C minus charge is there. Therefore, what you are going to get is ethyl plus C triple bond N. So, such a compound is called alkyl cyanide. CN cyanide, isn't it? Cyanide. So, ethyl cyanide is the product. Instead of sodium cyanide, you too can take a potassium cyanide also. Same reaction, you will get the ethyl cyanide. But instead, if you get the silver cyanide, AgC triple bond N. Now, here between the Ag and the carbon, there is a bond which is not like the plus minus. This is totally ionic. This partly some covalent nature is there. Therefore, the breakage of the silver carbon is not that easy in this case. But meanwhile, the lone pair and the nitrogen will take this advantage to attack as a nucleophile, and what you are getting is a reverse type of reaction. So, here N will become a plus, C will become minus. Okay. So, what is attacking species? Cyanide only, but on the other side it is attacking, therefore, NC is coming. Such a products are called alkyl isocyanides. Isocyanide means, iso means similar. It is not exactly, reverse is there, therefore, we have named as a isocyanide. Similar the case, if you take a sodium nitrite, NaON double bond O, here also bond is O minus Na plus. So, O minus will attack, or you can take potassium nitrite, NaNO2, either NaNO2 or KNO2. Both NaNO2 and KNO2, O minus will attack, therefore, what is the answer? ONO. These are called alkyl or ethyl nitrite. What is the product you have taken? ITE only. Nitrite I have taken, nitrite is the answer. Cyanide I have taken, cyanide answer. But silver cyanide reverted. So, similar the case here also. If you take silver nitrite, again the problem of it is not totally ionic, therefore, lone pair on the nitrogen is more nucleophilic rather than the lone pairs on the oxygen. So, therefore, the nitrogen will take this advantage, and what you will get is a bond between the N and the C is developed, and this is called what? Nitroalkane. Previously, alkyl nitrite, this is a nitroalkane is formed. Okay, nitroethane is formed. Nitroethane. See the case of the silver. This you can take as a silver magic. Whenever silver is added, reverse type of product is formed. See, silver cyanide, you won't get cyanide, isocyanide. Silver nitrate, you won't get nitrate, you will get a nitroalkane, isn't it? So, like that, a huge number of anions, we have a list of the big anions, all these anions will attack, including some the halogens also, like for example, if you take a alkyl iodides, alkyl chlorides or alkyl bromides both, and this reaction if you use a potassium iodide, the I minus will replace this halogen and you will get a alkyl iodides, isn't it? Within the halogens also the I minus happens to be a stronger nucleophile, it replaces the halogens. So, a big list of the substitution reactions are examples are there, all this of which the silver cyanide and the silver nitrate questions are several times repeated in the even the recent the EAMCET examinations. Now, let us go for a few more reactions. Alkyl halides also undergo second variety of reaction is Wood's reaction. Wood's reaction is alkyl halide when treated with the sodium or ethyl chloride. For example, ethyl chloride, the sodium dry ether will be the solvent. Even this, what is the solvent used in this reaction? Dry ether was asked. So, here the doubling reaction it is, sodium will take away the X, you take, so 2 Na 2X will be removed, R and R will be the product, that is the alkane. So, in the case of ethyl chloride, guess the answer, ethyl will be doubled, so therefore, answer will be the butane. If a butyl chloride is taken, then you will get the octane, or propyl chloride you will give the hexane, at exactly the R is replicated, doubled, so therefore, double answer will be. This is called what? A name reaction called Wood's reaction. Alkyl halides react with the, including the all alkyl halide, react with the magnesium metal. See, the sodium and magnesium very similar, but the magnesium happens to be less the electronegative. It happens RMgX, a temporary or highly reactive compound is formed. This compound has a lot of synthetic potentiality, but however, we have one simple application. If I add water, you will get RH. Alkanes are formed, isn't it? But this is not the great application. Preparation of alkane from alkyl halide is no more important. But the RMgX are very suitable. They add on the carbonyl compounds, carbon dioxide and so on. Huge number of applications are there. The RMgX is called what? Grignard reagent. Grignard reagent. The reagent also requires a solvent like dry ether, because metals when you are using, the ether will be the suitable solvent, should not have any dry ether, means no water containing ether. And another reaction is in alkyl chloride, if you use aqueous KOH, already we have seen, isn't it? Aqueous KOH, what happens? The OH minus replace and you will get alcohol. This is what a nucleophilic substitution reaction. But the same KOH, if you use alcohol, that is you take ethyl alcohol and dissolve this potassium hydroxide. It is soluble. That reagent is called alcoholic alkali. You can write like this, alcoholic alkali. It's a abbreviation. But what is alkali means? KOH. KOH solid you dissolve in alcohol, ethyl alcohol. That solution if you add and heat it, because of the stronger the base, one HCl molecule will be removed and you are going to get the alkenes formation. Right. So, ethyl chloride is going to result alkene. This is a elimination reaction. This is a elimination reaction, and this is a Wood's coupling type of reaction. Wood's reaction is a coupling reaction. This is because one alkyl group is joined with another alkyl, therefore it is a coupling reaction. The coupling reaction has an extension also. If a compound is two halogens like this, okay, if two halogens are on the same carbon, you can use zinc metal, and these two halogens and the other two halogens of other compound will be removed with the help of the two zinc, you will get an alkene formation. Even this is an extension to the same type of the Woods reaction, but if one halogen is there, a single bond is formed, two halogens, a double bond is formed. We have a further extension for this reaction. If a compound is having the three halogens like a trichloromethane, okay, trichloromethane, when you add silver metal, the three halogens will be removed and you are going to get a triple bond between this. So, you need a 6 silvers. This is also an example for the coupling reaction. Coupling reaction means two identical parts are going to join up, assembling, and you are getting. For all these reactions in non-aqueous mediums required, and you are getting this type of the, when 1,2, that is 1,1 dihalo compounds are there, you are getting double bond. 1,1,1 trihalo compounds are there, you are especially the chloroform. In the case of chloroform, this is an excellent example. All chlorines or bromines or iodines are going to give acetylene type of the product. Now, this is the gist of this preparations and the properties of alkane, except one the aspect, that is, in the alkyl halides, recently we have one small topic is introduced, that is substitution nucleophilic bimolecular, substitution nucleophilic unimolecular. This is a new terms used in the textbooks, that is a small explanation is needed here. What is this substitution means? Overall reaction is the same. Alkyl halide, when a Y is added, the Y replaces, you are going to get the RY. This is the net reaction. But in terms of the kinetics oriented, the reaction is subdivided into the two types. The S stands for the substitution, N for the nucleophilic substitution, 2 for the bimolecular reaction, 2 for the bimolecular reaction, and 1 for the unimolecular reaction, So, you can total expand here, unimolecular nucleophilic substitution, bimolecular nucleophilic substitution. Let us see the mechanism of these two reactions, in what way they are differing. Because the questions are going to come, in fact, because it is recently introduced the topic. There was no much questions on previous IIT this EAMCET papers, but now we are going to get some questions definitely on this SN2 and the SN1. So, in this SN2, you take a small compound like methyl chloride or small ethyl chloride compounds or small compounds you take, especially 1 degree. 1 degree means primary alkyl halides you take and treat it with the aqueous sodium hydroxide. Now, the bond is polarized. There is a delta minus on the Cl, delta plus on the carbon. Delta minus will be repelling the OH, therefore, of this Cl minus, either from this side or that side, the Cl minus will be repelling. So, therefore, the OH minus try to attack this Cl plus and comes from the rear side of the rear side means what? Back side of the Cl. Exactly the symmetry of this alkyl halide will, the 3 hydrogens will be there. The OH, if you take opposite side of this one, back side of this one, between the 3 hydrogens it will come, there will be a lot of space will be there. Slowly OH will be coming, so it is going to make a bond formation. Simultaneously, Cl is going to detach. You can find a transition state. This is called what? A transition. Transition state is different from the intermediate. Transition state is different from the intermediate. Intermediate is called when completed. This is not at step 1 completed. It is not the OH introduced nor the Cl is eliminated. Both are partly. It is slowly making the bond. Cl is slowly departing from this site. Finally, what happens means Cl will be Cl and this Na will be formed, no doubt. Okay. But what about this? The OH means OH comes from the opposite to the Cl, therefore, see opposite side OH will be there. What about I can't write hydrogens also this side. So you have to write the hydrogens other side. We know the symmetry of this one is 109 degrees. So all the hydrogens which were here, if when the OH comes here, slowly travel hydrogen from this side and they fall that side, isn't it? So they a sort of the molecule undergoing inversion. A scientist called Walden explained a beautiful explanation. When you are carrying a umbrella, a strong wind enters perhaps. If the umbrella goes that side, this is called a inversion, he says. So like that, a molecule also, when OH enters, the hydrogens fall that side, isn't it? So when it is now in the transition state, means they are neither left side nor right side, probably they are on the middle, isn't it? So this makes one a plane type, either that side or this side. It becomes permanent, the hydrogens fall that side in order to maintain this 109 degrees 28 minutes. That's all. The molecule undergoes a inversion called Walden inversion. This is called what? Walden inversion. What is the influence on the molecule? Means on the methyl chloride there is no influence. However, instead of the methyl chloride, if you have a compound like one is hydrogen, one is deuterium, one is a methyl, then the chlorine is there. This compound happens to be a optically active. Then if the reaction takes place, will be on the left side, and H, D and the methyl will be on the right side. Then the symmetry is exactly opposite. If this happens to be a plus compound, this if the original compound is minus, the product will be the plus. If this is the minus, the resultant compound will be the plus. So the optical activity is totally reversed, isn't it? Minus compound will become plus, the dextro compound will become levo. But if the compound is not having optical activity, there is no this one, isn't it? So, but what is the value means? Let us examine here. A plus 25 I have taken. Plus 25 I have taken. Do you get a minus 25 means you may expect, but this is alkyl halide, that is alcohol. So you can't compare the values. It is definitely minus, but it may be a minus 35 the alpha, isn't it? So therefore plus will become minus, but we can't guess the value. Value can be some other value. So here why you are calling the 2 means there are 2. It looks like 2 steps, but the whole thing is a concerted mechanism. It's only one step. The reaction passes to only one step reaction. So therefore rate of reaction is directly proportional to the what are the constituents in this reaction, right? Another one is the alkali, the OH. So therefore the reaction is called what? Bimolecular. Two molecules involved in the rate of this rate determining step. So it's only one step in fact. In that step the reaction is a bimolecular reaction, isn't it? What are the 2 molecules? One is alkyl halide, one is OH. Either one you increase, the rate of reaction is going to increase. Either one you decrease, rate of reaction will become slow. Then let us go for this SN1 of reaction. Primarily we have to propose a compound with slight difficulty. What is that? The groups will be all bigger groups you are going to propose. That means this alkyl halide is no more a, especially a 3 degree type of the alkyl halide you have to select. Then the reagent is common, that is aqueous KOH or NaOH. KOH or NaOH. Similarly, it will travel from this side, it will have a negative repulsion, therefore it will try from the back side. Back side means what I said, a rear side attack. Even this rear side attacking is also not possible because of the phenomenon called what? Steric hindrance. Steric hindrance. This is nothing but there is no place to attack. All the alkyl groups are big now. So from the back side they are opposing them because due to the no space availability, even the back attacking is not possible. Then how the reaction takes place means we have one positive points. What are that? All these alkyl groups are pushing. This is called plus I effect. How many alkyl groups? 3 are there. Therefore the maximum pushing effect will be there. First Cl will depart. So step 1 is known as what? Minus of Cl means an ion is formed. Therefore we call ionization. Ionization halide is taking place. This is called what? Step 1. This happens to be the slow step. Ion formation will be the slow step. What type of the ion means? The carbocation is formed. This carbocation will have a specific symmetry called trigonal planar. Trigonal planar, because it is a sp2 hybridized carbon and it will have a trigonal planarity. Now the OH is not having the problem that front side Cl was there, it was not there. So that problem is solved. Back side all the alkyl groups are one-sidedly arranged. There was no space. Now the alkyl groups have become like a three-side tree. So therefore OH can side or from the back side. Therefore it goes to the two types of the answers. One is the symmetry similar to this one. Similar to this one means the OH will be coming from the same side of the Cl. So the alkyl groups will be this side only. This is called retention in configuration. Retention in the configuration. The other side of the OH will be this side and the alkyl groups will be the other side. So this is called inversion in the configuration. Inversion in the configuration. So what is the chance of getting front side and back side? Both are. Again here, if you take all alkyls are same, therefore there is no much influence. But if the compound is optically active, when you get optical activity, if R1, R2, R3 are, then this one is methyl, one ethyl, one propyl. If you select, then it is optically active. Let us say a dextro compound is their positive value, then it will become half will become negative, half will become positive, and these two happens to be same value because that is alcohol. If this value will have a plus 35 value, this will have a minus 35. What is the net value? Net value is alpha is 0. So such a type of mixture is formed in this equal amounts of dextro levo. Such a mixture is called what? Racemic mixture. So if the compound is optically active, in SN1 reaction you are going to get a racemic mixture. In the SN2, if the plus is taken, minus will come. Optical activity will be inverted, and there are two steps are there. This happens to be a minus attacking on the plus, ion versus ion, very fast reaction. So therefore rate of reaction in this reaction is only dependent on the slow step, that is alkyl halide alone. Rate of the reaction is dependent only on the alkyl halide but not on the base. The base is coming in the second, which is a very fast step. So that won't be the rate determining step, only this will be the rate determining. So therefore there is a number of the comparisons are there, as well as a number of differences are there in the reaction. Let us go to some of the questions which are asked in the previous years. Next. Which of the following feature is not observed in SN2 reaction? First of all, this is the one. So in the SN2 reaction, first one is the SN2 reaction. It is one step reaction. Yes, it is a one step reaction. SN2 is a one step reaction, but it is dependent on the two species in the rate determining. 2 stands for the bimolecular, not 2 steps. So therefore it is a one step, correct. 100% correct. Intermediate carbocation is formed, that is wrong, because it is goes through the SN2 goes through transition state. SN1 is here, the carbocation is present. Primary alkyl halides prefers, that is also correct. So wrong one is third one. Next. SN1 is not characterized by, that means 3 are characteristic points are there, one is wrong, one is there. Oftenly rearrangements takes place. When rearrangements will takes place? When a compound passes through the intermediate carbocation rearrangements. So carbocation is there in the SN1. SN1 passes through carbocation trigonal planar, therefore rearrangements will take place. Polar solvents induces this mechanism. Yes, there are ions are involved in this reaction. Therefore, ions leads to give this polar solvents induction property. Rate of reaction is directly proportional to only Rx. Yes, this is also one of the feature of the SN1. Transition state is involved, that is wrong. Intermediate carbocation, the fourth one is the wrong one. Fourth one is wrong one. Next. The chloro group when present on benzene shows, this is a halo alkane. In fact, in the last class we have explained certain points regarding the chlorobenzene. certain points regarding chlorobenzene. So, we will take up a small note on this chlorobenzene and then we can answer this. This can be prepared from the benzene. First of all, how it is prepared means from benzene, chlorine and anhydrous ferric chloride is required and heat it. This is an electrophilic substitution reaction. You can get this reaction. This is the best method of the preparation. Now, under this, the influence of this halogen, especially in the syllabus of the EAMCET, it is mentioned. Under the influence of the Cl, what are the influences means? For Cl will have a minus I effect. Through the sigma bond, it is inducing electrons. Over the sigma bond, it is donating a pair and it is showing the resonance. Therefore, this first group is known as plus M group and the benzene is showing a minus M property. So, therefore, chlorine is showing simultaneously two effects. One is minus I, the other one is plus M, which is a minus sign plus controversing feature. However, minus in the ring deactivation. You do any electrophilic substitution, chlorobenzene is lagging little. And when you are doing any introduction of the electrophile, plus M effects, because of the plus M effect, ortho, para, ortho will be negatively charged. Therefore, new group goes to the ortho and para. So, what is the influence of chlorine means? In the electrophilic substitution, rate of reaction it decreases. However, goes to the electrophile goes to the ortho para. Based on that, the questions are there. Chloro group when present on benzene shows minus I effect and plus M. So, therefore, 1 and 3 are the right answer, that is answer 4. Next. Which of the following compound shows slowest reactivity towards nitration? See here, methyl is a plus hyperconjugation, reactivity increases. Phenol, second one, OH plus M group, reactivity increases. Cl minus I dominating, therefore, reactivity decreases. OCH3 is a plus M group, methoxy group. O has a lone pair, therefore, plus M. So, therefore, only third one is the rate slow will be there. Next. With reference to the chlorobenzene, which of the following statements is correct? Recently, the question in the last year it was asked. So, the chlorine is ortho para directing, it is right. What is he wants is a wrong statement. Which of the following statement is not correct? So, the chlorine is ortho para is the right statement. Chlorine exhibits the plus M effect, right. Chlorine is ring deactivating, right. Generally, plus M groups activates, but this has got a exceptional property, ring deactivating. Chlorine is meta directing, that is a false statement. Next. Consider the following reaction in this ethyl chloride with sodium silver cyanide. As I said, silver gives a reverse type of the reaction. So, you are expecting what? NC. NC means isocyanide. It gives a propionic, this isocyanide. Which of the following statement is true? And that is propionic acid on hydrolysis, gives propionic acid on hydrolysis. Cyanide, if cyanide comes, propionic acid comes. It has an ester functional group, wrong. It has a nitrogen linked to ethyl carbon, that is right, because isocyanides will have a NC relation. So, nitrogen linked group is coming. Therefore, third one is the right answer. It has a cyanide group. So, that is 1, 2, 3 given here in the second statement. So, in the second statement, third statement is right, he says. Therefore, second answer is right, that is third statement is right, second answer is right. Next. Watch the following columns here. The column 1, ethyl chloride with moist silver oxide. Moist silver oxide means silver oxide will be anhydrous, then the moist means water added, it will become into silver hydroxide. A OH is replacing the Cl. So, therefore, what you will get is ethyl alcohol. So, the A third one, where is there? So, only one option, that is the third question, A3, B4, C1, D2, that is B will be ethyl chloride. Let us examine ethyl chloride aqueous ethanolic cyanide. It's sodium silver cyanide, you will get a NC, that is the fourth one, answer right. And the C bit, ethyl chloride aqueous ethanolic silver nitrite will give a ONO. If it is sodium nitrite, sodium nitrite will come, isn't it, right. Then silver ethyl chloride ethanolic KOH elimination takes place, ethylene will be the answer, that is answer 2 is the right answer. Next. the correct structure of the 4-bromo, it is a nomenclature question, 4-bromo 3-methyl. So, the numbering is from the ethyl ene side, not the halogen. Halogen is least preferred over the alkenes. So, therefore, first ene is given preferences. In the second compound, the ene is given 1, 2, 3, 4 and the fourth carbon bromine is there. So, therefore, 4-bromo. However, alphabetical order bromo comes first. So, 4-bromo 3-methyl but 1-ene goes to the second bit. Next. The metal used for the debromination reaction of 1,2-dibromoethane. Debromination for the 1,2-dibromo, zinc is used and zinc eliminates 2 bromines as zinc bromide. So, alkenes are formed. So, second option is right. Next. Consider the following reactions, X plus HCl, you are getting ethyl chloride, probably X must be the ethylene, right. Then this ethyl chloride, also can be prepared in the second step. Y is giving ethyl chloride. Compound Y, the reagent is Lucas reagent, anhydrous zinc chloride and HCl. So, Lucas reagent substitution, he has given a clue also what type of reaction it is. So, the Y is giving ethyl means Y must be ethyl alcohol, X must be ethylene. So, now the question is Y can be converted into X, that means ethyl alcohol to alkene, is a dehydration reaction. It comes under, however, partly from the alcohol chapter. In the next tomorrow we will see this alcohols, but the answer is 1, and the alumina and 350 degrees are sulfuric acid concentrated at 170 beyond, that is not there. So, the question answer 1 is the right answer. Next. In the reaction sequence, ethyl chloride KCN, you will get a ethyl cyanide. Ethyl cyanide and hydrolysis will get propanoic acid. So, the propanoic acid means 3 carbons should be there with a COOH, means answer 1 will be the right answer. Next. Which of the following reaction proceed via a secondary free radical? The first step, in the first reaction, HBr is added. First H will be added on the terminal carbon, 2-degree carbocation will come. He is asking second free radical. Free radicals are generated actually in the HBr in presence of peroxide, but here it is UV light is given. Even UV light breaks the HBr into dot. It is a rare case actually. First Br dot will be attacking on the terminal carbon, leaving the 2-degree free radical on which H dot will be added. You will get a Marconi after type of the answer, that is answer goes to the second. Next. In chloroethane, the carbon bearing halogen is bonded to hydrogens, dash number of hydrogens. It is called dash type of alkyl halide. So, in the ethyl chloride, the chlorine attached to a carbon, first carbon on which 2 hydrogens are there, 2, and the type of alkyl halide, it is a 1 alkyl group and 2 hydrogen, means it is a primary alkyl halide. Classification of primary, secondary, tertiary carbon is the one of the point here. So, the answer goes to the 1. Next. In the following reaction, A and B respectively are. So, A with HBr ethyl bromide is formed. Probably HBr was added to A must be alkene. Or even it can be alcohol also, substitution reaction gives the ethyl bromide. So, A can be alkene or ethyl alcohol. Now, let us see what is B. If B is the ethyl bromide, B is added, A will become a again alkene. Yes, if B is alcoholic KOH, again alkene will be formed. If A is alcohol, then you shall have to take aqueous KOH. There is some ambiguity is there. I think this question needs an ambiguity resolving is now we have to go for the 1 and 3, both answers are right. Ethylene on adding HBr ethyl bromide, alcoholic KOH, again alkene will be formed. Or you take ethyl alcohol starting material, you add HBr alone can replace the OH, does not require any catalyst here. You will get a bromoethane, which on aqueous KOH again ethanol will be formed. So, you have really 1 and 3, both are right answers. Next. The reaction conditions used for the converting 1,2-dibromoethane 2-ethylene or 1,2-dibromo means vicinal type 2 halogens can be eliminated by alcoholic KOH. Alcoholic KOH, when you use you will get the 2 halogens will be removed. But if you really use alcoholic KOH, you may give this alkynes, 2 halogens with 2 hydrogens. If you remove, you will get alkyne. But here ethylene you want, so therefore zinc and alcohol, that is the answer 1 will be the right answer. Next, ethyl iodide with sodium ethoxide. Sodium ethoxy group replace the iodine to get a ether. That ether with Hi, you will get again 2 moles of ethyl iodide. 2 moles of ethyl iodide. So, the Y will be the ethyl iodide, X will be the ether. So, what is asked here? Y is asking, Y is the ethyl iodide. So, answer goes to the 2. Next, chloroethane reacts with magnesium, that means RMGX is formed. Okay, to form X is RMGX. Hydrolyzed a carbon compound Y, that is a ethane is formed. Z is a magnesium hydroxychloride, leave it. Y is a ethane. So, Y means that is compound 3, C2H6 is the ethane. Next, ethylene reacted with bromine in chloroform to form X. CCl4, ethylene reacted with bromine in CCl4, only a solvent here, don't get confused. So, ethylene will be added with bromine means, so you will get a 1,2-dibromo. This 1,2-dibromo alcoholic KOH eliminates 2 moles of HCl, gives acetylene. So, to give the Y means Y must be the acetylene, X must be the dibromo compound. So, answer 1 will be the right answer. Next, the chloroethane reacts with Y to form NaCl. The slightly ambiguity is there. To form NaCl, a byproduct NaCl is showing. So, the introducing group we do not know, but that compound 1 mole of Z reacts with 2 moles of Hi. Hi gives a clue here. Hi readily reacts with ethers. So, Z must be the ether. To get Z ether, what must be the Y? Y must be an alkoxide. Alkoxide reacts in alkyl halide, that is the Williamson synthesis. So, ether comes, ether reacts with Hi to form the water and iodoethane. So, therefore, the compound Y must be sodium ethoxide. Answer goes to the 4 therefore. Next, the chloroethane is treated with alcoholic KOH. It is a strong base eliminates the compound is alkene, that is C2H4. Answer 3 is right. Aqueous KOH, remember it is alcohol comes. Alcoholic KOH means elimination, alkene comes. Next, the solvent used in the preparation of Grignard reagent is, solvent used for Grignard, dry ether. Answer 1. Dry ether is the answer. Alcohols and all that will react. In fact, the dry acetone, for example, second example, second one is a carbonyl compound. The moment RMGX comes, that will react with acetone. If alcohol comes, RMGX undergoes hydrolysis. Therefore, and the 2, 3 will be the wrong answers. 1 will be the right answer. Dry ether. Next, reaction of benzene with alkyl halide in presence of anhydrous aluminum chloride, as shown. The alkylation of the benzene takes place, and this reaction happens to be a Friedel-Crafts alkylation reaction. Answer 1 is right. Next, when an alkyl halide reacts with an alkoxide, ether is coming. So, the answer is ether. Third answer is right. Alkoxy nucleophilic substitution of the alkyl halide gives ethers. Next, in which one of the following conversions phosphorus pentachloride is used as the reagent. PCl5 is used on the alcohols to give the alkyl chloride. So, that is the third answer is right. Alkenes to alkyl halide, HCl should be added. Ethers to alkyl halide, that is also methyl, we can't get. Ethyl chloride means for some extent PCl5 are the breaking reagents you can use, but the product is methyl chloride that you won't get. So, acetylene to vinyl chloride, HCl is addition reaction. So, the PCl4 means PCl5 means definitely third one answer. Next, the hybridization state of carbon atoms in the product formed by the reaction of ethyl chloride with aqueous KOH means ethyl alcohol is formed. Both the carbons of ethyl alcohols is sp2. there is no ambiguity, therefore answer goes to the third answer. Next, ethyl chloride on heating with silver cyanide forms a compound X. So, the ethyl silver cyanide, as I said, sodium cyanide gives cyanide, silver cyanide gives isocyanide, but he is asking functional isomer of this isocyanide. So, you need a cyanide. So, the second answer is right. Actual answer is isocyanide, but he is asking functional isomer for that isocyanide. Isocyanide functional isomer means cyanide. So, the second is the right answer. Next, which of the following reagents and conditions convert benzene into chlorobenzene? You need a chlorine, aluminum chloride or ferric chloride, some anhydrous, the metal catalyst and the chlorination, electrophilic substitution, chlorine sunlight, free radical substitution. If a methyl benzene is taken, perhaps the chlorine sunlight makes the benzyl chloride, that is chlorination takes place in the side chain. Next, alkyl halide reacting with metallic sodium in dry ether solution called that is alkoxides. Alkyl halide reacting with metal, what is the reaction? Gives the higher alkanes. Okay. Next, what is the reaction? Next, the products formed when ethyl chloride is treated with silver cyanide. So, repeatedly silver cyanide is coming. When you use sodium and potassium cyanide, you will get cyanide. Silver cyanide means isocyanide comes. So, isocyanide means NC. Second answer is right. Next, the number of structural isomers possible for the C3H6Cl3. That means there are 3 carbons. I will work out and show it. Is in fact, you cannot easily guess it here. So, we have 3 plus 2 plus 3. Total 8 hydrogens are there, of which 3 chlorines are there. So, you can have a 1,1,1 trichloropropane, you can have a 1,1,2 you can have 1,1,3 also, okay, 1,1,3 trihalo. You can also have a 1,2,2 trihalo, you can also have a 1,2,3. Why not 1,3,3 means from that side it will become 1,1,2. So, therefore, totally 1,1,1 trichloro, 1,1,2 trichloro, 1,1,3 trichloro, 1,2,2 trichloro, 1,2,3 trichloro, total 5 different combinations, a probability type of the answer, 5 different trichloro product, that is answer is 3. Next, the compound which gives N-hexane on heating with sodium in dry ether. So, you must take 1 chloropropane or 1 bromopropane, that is N-propyl bromide, answer is 2. Next, ethyl bromide on treatment with aqueous KOH, that is ethyl alcohol comes. So, answer 3. Aqueous means alcohol, alcoholic means ethylene, alkene, okay, ethyl alcohol substitution. Next, ethyl bromide on boiling with the alcoholic solution of sodium hydroxide. Ethyl bromide on boiling with the alcoholic solution of NaOH, that is alcoholic base means alkene will be the answer. Alkene means ethylene. So, answer goes to the 4th answer. Next, so with this we can have a conclusion here. Alkyl halides will have a 2 important reactions. One is specifically nucleophilic, the substitution reaction. The other one is we are observing elimination reaction. Aqueous KOH means substitution, alcoholic KOH means elimination. Apart from that, alkyl halides with the sodium, we are getting a Woods reaction, that is doubling of the reaction. With metals like magnesium, RMGX formation is taking place, right. So, these are the 4-5 reactions important, and recently introduced the SN1, SN2 mechanism also important with reference to the mechanism, intermediates, comparison, and the that is optical activity, how it differs, and all that points also we are going to observe in this alkyl halide. Tomorrow we will have the continuation of this alkyl halides. However, with the trichloromethane, a special compound. This is also an alkyl group, but 3 halogens are on the 1 carbon, that makes slight difference. Such a type of compound we will take on the tomorrow, that is chloroform we will take in the tomorrow, right. Thank you.